Recording in progress.
Yeah, comes on everyone. Hope everyone has gone through the notes. Let's go ahead. So this was the last thing we did. Let's start off with a question. We have a spring here. K is 100 Newton per meter. And we got a block here of 2 kg. And this is 80 centimeters. So the block is pushed against the spring. By 10 centimeters and released. You ever played with a dart gun? You push the dart against the spring, right? And then you shoot. So when you push it and by 10 centimeters and released. So the block flies off the table. So after doing that, so this block will fly off the table and land on the ground. Find range. So initially the block and the spring are not attached. Then you pushed this block against the spring by 10 centimeters and then you left it. Find the range. Others, do keep your cams on or no, Taksha? Who is missing? 0.4√2. Okay, numbers are not good. Kya? Devika, your cam is blank as usual. Answers, everyone. We have one answer, 0.4√2. I thought I gave good numbers. I gave bad numbers. Kya? हो सकता है. Anyone else? I'll give another 30-40 seconds. 0.4√2. Yeah, it looks like most of you are getting the same one. So what is the catch here? So initially this was the scenario here. The block was compressed here. And then the finally block comes here. So this is your speed V. So this is your state 1. This is your state 2. Both are at the same height. So I'll take this as reference line. So energy in state 1 is equal to energy in state 2. Gravitational potential energy is 0. Spring energy is half kx square. Kinetic energy is 0. Here kinetic energy half mv square, spring is 0. Agreed? I'm skipping the steps. Meaning I can write gravitational potential energy is 0. Spring energy half kx square. Kinetic energy is 0. State 2, gravitational potential energy is 0. Spring energy, the spring would be disconnected now, so that would be 0. Kinetic energy half mv square. So I can say all the spring energy became kinetic energy. So this is half k 110 centimeter is 0.1 ka square. Half mass, I should have given 1 kg. So 2 will go off. That would be, this will go off. So V is equal to 1/√2. What is time of flight? Root over 2h by g. That is 2 into 0.8 by 10. That is 0.4 seconds. What is range? V into time. Easy. So when you push it against the spring, and basically that becomes your kinetic energy and that velocity, and you get a range. It becomes a kinematics question. Clear, na, Arnav? Devika? Clear? Arya? Arush? Ojas? Next one. We have a spring, an unconventional spring. We have a non-standard spring. Whose force F is given by minus kx cube. Normally force used to be kx, na? X is elongation or compression from natural length. K is the spring constant, normal. There was a correction I wanted to do. This was the mistake I did. This, no, time varying forces are not central forces. I started thinking, think about this. Means if you're going from point A to point B, depending on the time, the work will be different, isn't it? If you go from A to B, even though this is a central force, if you look at this, depending on which time you're going from one point to another point, the work done will keep changing. And if the work done, that means work done is depending on time. So you're not getting the same work from A to B. So time varying forces are never conservative. So that was a mistake I did. So that was a correction. Since we get different work for different times. Just think about it. If you're going from A to B at one time, you'll get some work. If you go at another time, you'll get another work. So our work is changing. We get different work from A to B at different times. So if you have a force which is changing with time, it is always non-conservative, even though it's a central force. That was a correction. Clear? Keep that in mind. That was a thing. Next. So this is a thing there. So the question is, the work done to stretch from x is equal to 0 to x is equal to x naught is W. So this non-standard spring, when you want to stretch it from 0 to x naught, it took work done W. Then they'll frame the question like this. Find the work done to stretch from x is equal to 2x naught to x is equal to 3x naught. Remember, you can't use half kx square. Half kx square was derived when the spring force is kx, isn't it? The spring energy is there, na, half kx square. When did you derive that? You derived that, if you go back to the derivation, that formula was derived under this condition. When the spring force is kx, you got energy half kx square. You messed up the force only. So this formula is not valid anymore. I hope you're getting it. So you need to calculate the new potential energy for spring. That's why it's a non-standard spring. So your standard results won't be valid. Let's try. Anyone didn't get the question, please ask me. 65. Let's see. First thing, go back to the definition of potential energy. So work done by the spring force will be integral f dx. This would be minus kx cube dx. This will be minus 1 by 4 kx power 4. This will be negative of potential energy. So the potential energy of the spring, this spring this is 1 by 4 kx power 4. So the potential energy of the spring itself will change. This is not half kx square anymore. It is something else. Now you want to go from work done from 0 to x naught. The work done is nothing but change in potential energy plus change in kinetic energy. The work done by external force is change in potential plus change in kinetic. In our problem, there's no kinetic energy, only spring is changing. So this would be 1 by 4 k x naught power 4 and initially 0. This is W. Now you want to go from 2x naught to 3x naught. This will be 1 by 4 k 3x naught power 4 minus 1 by 4 k 2x naught power 4. So if I take out half k x naught power 4 common, this will be 3 power 4 minus 2 power 4. This is W. This is 81 minus 16. That is 65 W. Clear? That is the first thing. So you can't use your standard energy formula. You have to create the new spring energy there and then you have to solve. Is this making sense, everyone? This is how they'll frame questions. Not a tough one, but yeah, they should know, like, the moment you see the force kx cube, you should know, yeah, this is not a normal spring. So all those formulas are not valid. Next one. Any doubts on this? Devansh? Clear, na? Pratik? Vignajit? Nikhil? Great. Next one. We have a block of mass m here. We have a spring here. This is k. Let this be height h, which is 2 mg by k. The block is released from rest. Gravity is there. So what do you think will happen? This block will fall on the spring and the spring will compress. And then the spring will push the block up again and again it will fly. The block will come down, again it will fly and so on, right? The block will keep going up and down. Now we will not get into that part that we will see later in SHM. There I'll ask you find time. But for now, find the maximum compression in the spring. Find the maximum compression in the spring. I can add one more question. At what position block has maximum speed? Now this becomes an advanced question suddenly. I can ask this in more than one choice. Let's get these two. Answers are bad. You will get in roots. Try. I'll give you a minute more. No. Right, Poroja. You got it. No, Arush, that is wrong. Let's try to analyze the diagram. What is happening? See, this is important. When you get a question, right, analyze like, okay, what is happening? What are all the steps that are involved? So let's see how it looks. So this level is your natural length. That is when the spring is neither elongated nor compressed. So you left the block from here, mass m. Initially, speed is 0. Now, when the block comes and hits here, now this is a common mistake. People think here the speed is maximum. Now, if you look at this, ask yourself, at this point, what are the forces on the body? Mg. If you look at the forces on this body here, there is mg. The spring force kx is 0 because it is in natural length. So acceleration is downward. And here, what is the acceleration? Acceleration is g. So, and what about the speed? Speed is also down. Now you tell me, if you have speed downward and acceleration also downward, will the speed increase or decrease? Speed will continue to increase. So this point where speed is not maximum, the block will continue to go further. At some point here, x, at this position, if you look at the forces, this would be mg, this would be kx. So when the spring force kx becomes equal to mg, the acceleration becomes 0. You're getting it? This position is called as equilibrium position or mean position because net force is 0. Equilibrium doesn't mean you will be at rest. Equilibrium meaning force is 0. So at this position, your speed is maximum. By next moment, you're going to decelerate. At this position, the speed is maximum. The most common mistake what people think is, sir, once you push here, spring is pushing, it will slow down. No, mg is still greater than kx. In this scenario, mg is greater than kx. So speed will increase. When mg becomes equal to kx, next moment kx will dominate. So after this point, kx becomes greater than mg and the body slows down. So our second part ka answer is this. So at when the compression x is mg by k, the speed is maximum. It is not when the spring is in natural length. As long as kx, mg is greater than kx, speed will keep increasing. Maybe it is not increasing as fast as before, but it is increasing. Question is still not over, so it won't stop here. Are you getting this? Is another mistake. Sir, 4-0, it will stop. It will stop when velocity is 0, not when force is 0. But because of maximum speed, this block will still continue to go further and eventually will stop somewhere here. This is your maximum compression. So if you define your states, this is my state 1. I didn't ask you for speed, so this is state 2. Is this analysis making sense, everyone? So first the block will fall, then it will hit the spring, then it will compress the spring. Mg and Kx both are fighting. Mg is greater than Kx initially, right? So it will speed up. Once Mg crosses here in this point, Kx becomes greater than Mg. Now the block is pushed up again. So this block will never stop. It will just keep on bouncing up and down. So we have to conserve energy between state 1 and state 2. State 1, I will take my natural length only as a reference line. State 1, gravitational potential energy, mgh, this height was h. Spring potential energy, 0. Kinetic energy, 0. State 2, gravitational potential energy minus mgx, I'll let xn. Spring potential energy, half k x square, I'll just write x. Kinetic energy, 0. Since there are no external forces on the system, energy in state 1 is equal to energy in state 2. We get mg h is equal to half kx square plus mg minus mgx. H ka value is given as 2mg by k. This is 2m square g square by k. Half kx square minus mgx. Bring all x to one side. We get half kx square minus mgx plus minus 2m square g square by k is 0. It's a quadratic. X is equal to mg plus root over minus I won't take, you'll get a minus sign then. B square, that is m square g square minus of minus 4 a half k, and this is 2m square g square by k. It looks messy, but 2 into k by 2. K will cancel. 2 will cancel, that will be 5. You end up with mg by k root 5 plus 1. Meaning this is all solving, meaning main thing is this. Please have a look at this page. This is how you analyze a problem. You should know each step mein what is happening with the block. Anyone not convinced with this diagram, please ask. So if I have to write now, from here to here, speed is increasing. Here to here, speed is increasing. From here to here, speed is decreasing. Because after this point, kx becomes greater than mg. At this point, mg is greater than kx. That's a very good question. At what point speed is maximum? Most people think at this point speed is maximum. Yeah, you can calculate, Ansh, and you can tell me what you got. Why will I tell you everything? Exam, who will come and tell you? You know everything, right, Ansh? Don't you know? Don't you know potential energy? Right? Don't you know kinetic? See, this is state 1. Ansh is asking, sir, how to find the speed here. Think about it. This is state 1. This is state 3. What is potential energy? Minus mgx. What is x? Mg by k. Isn't it? This x is mg by k. What is potential energy? Minus mgx. What is spring energy? Half kx square. What is kinetic energy? Half mv square. That is equal to mgh. Ho gaya na? You'll be able to calculate that. Okay, you got an answer. G root 3m by k. That I'm not sure. That I am not sure. So I will check. Why did you do that, but? Okay, it's a good question, but that's a good question. All clear? Let's see next one. This is a good one. This thing, right? We will actually see a question later on. Find the time taken for it to go and up. That would be a deadly question. That would be an advanced question. Oh, usme to it'll be fun. It looks like this. Where was that? Sure, I did. Here, this was the same question. We will get a beautiful answer like this. Again, if you see the same diagram I drew, exactly same diagram, but that is the actual question. It'll be an advanced paragraph question, so then they'll ask you this and that. Let's see one more. We have a spring here. This is K. This is block M. You gave speed U. This distance is D, and this is rough. Let's call it mu. Find max compression in the spring. नहीं रे अंश, that answer is wrong. You'll get something like √5 mg square by k कुछ आएगा. √5 आएगा. √3 नहीं आएगा. ट्राई करके मुझे वर्किंग बेस दो. I'll tell you what went wrong. Again एक बार और try करो and let me know. Let's get this one, everyone. We'll be playing with springs for some time. Now there is a friction also. मतलब this block won't hit the spring with speed. It will slow down. Again, just remember this thing. The spring will stop compressing when the speed of the block becomes 0, not when force becomes 0. I know numbers are bad. Just get the equation. If you got the equation sufficient, it's fine if you don't simplify. Numbers are given, you'll be able to handle it. Try, I'll give you a minute. Get the equation right. Show you? Always draw your final diagram. Most people don't do that. They don't draw their final diagram. They don't visualize what is happening. Physics में that is the most important thing. Visualizing how does the situation look after some time. If you can't do that, you will have a problem. And when your visualization becomes so strong, sometimes you can see and you'll get a lot of insights. You see a question, you get a feel like, oh, इसमें ऐसा होना चाहिए. And that is how you can speed up. So when this guy hits here, this is the scenario there. The block will hit somewhere here and stop. So from this position, let's say the block has traveled extra distance x. Now remember, during this entire process, friction is acting backward mu mg. You cannot conserve energy. There is a work done by friction. So work done by friction is minus mu mg d plus x. That is the thing. Be careful. It is not mu mg d. That is one mistake people do. You're done. State 1, state 2. State 1, potential energy, gravitational potential energy is 0. I'm taking the ground as reference. Kinetic energy half mg square. Spring potential energy is also 0. State 2, gravitational potential energy is 0, same level. Velocity is 0 because it's a maximum compression. Kinetic energy is 0. Spring potential energy half k x square. We know work done by external forces is E final, that is energy in state 2 minus energy in state 1. This is minus mu mg d plus x. E final is half k x square minus half mu square. But you get a quadratic. So you'll get x ka value here. I'll leave it there. If you got that equation, you're done. Is this clear to everyone? Now, a more intuitive way of thinking, I generally don't do like this in the exam. What I do now, I do like this. I know work done by friction. This I can calculate mu mg d plus x. So this is what I say normally. See what I say. Initially, I had half mu square. In that, friction took away this much energy. I had half mu square and friction took away this much energy. The balance went into the spring. So I will say initially I had half mu square. Then friction ate some energy. The balance went into the spring. Does it look more intuitive? Whatever you had initially plus whatever you lost, the balance must go somewhere. That will go into the spring. Same thing. I'm using work energy theorem, but I do like this. But if you think that is confusing, you can always follow the standard procedure. Whatever I'm teaching you, right? See, again, I'm telling you, whatever I'm teaching you, I always teach you a standard process, because when you go to an exam, when you're under full tension, the standard process will still work. But while solving, if you realize, there's a much better way you can do and much faster way you can do that suits you, okay? I think you should do that. But be confident. Will I be able to do this method in the exam? I hope you're getting it. I'm not saying my methods are superior. My methods are designed to make sure even in a very extreme under stress situation, still you'll be able to solve with the steps and get answers. So some of the methods I teach you are not efficient, but they are like, you can be sure like, this will work. I hope you're getting the difference. But if I was a student, I will never do this thing. I will feel this is unnecessary waste of time. Writing this, there is a lot of extra steps. So learn that. That's what I'm telling you. You should do that. You should learn to skip steps. But assuming you know how to do the process properly. Are you getting it? So be careful about what I said. Blindly just don't follow the teachers. There are some methods which you might be more comfortable with. You should go ahead with that. Nothing wrong. As long as your method is right and you think you're confident about it, you should do it. Clear with this? But standard process always works. For example, if you got stuck in a question, the standard process is the best thing to start with. That's what I want you to do. I want you to have your own ideas. I want you to have your own logics. For example, when my chemistry teacher was teaching organic, right, I could really never understand what he was talking. Meaning that NO2 plus M effect and all that. I understood, but वो कभी feel नहीं आता था. Then how I started learning? So I and my friend, we started learning in a very weird way. It's like, I don't know, organic has started for you. O2 has extra electron pairs. So this thing will give you. So in our story, right, O2 is a good person who will give electrons. NO2 is a bad person who steals electrons. Fluorine is a bad person who steals electrons. So bloody entire organic, how we studied? When we have a benzene, something called resonance, we used to study like this only. It's like when someone used to ask me to explain, oxygen is a good person, so it will give the electrons from here to here, so the bond will shift here. So when the electrons go here, so all the carbons will say, "Mujhe bhi ek electron." Then I said, "ठीक है, तू लेना है थोड़ा time." Then this will shift here, then this will shift here. Now, if there's an NO2 molecule, this is a bad person. As these electrons are coming, it will absorb this. It will not share with anyone. Literally, entire thing I studied, plus M and minus M as good person and bad person. This guy is a bad person, steal electron. That guy will absorb electron. That this any nonsense. So people never used to ask me chemistry ka doubts. And again, in the class, my chemistry is one of the best when it comes to marks. My physics and chemistry were pretty good, but my chemistry ka explanations, only other than my friend, no one used to understand. My organic explanation used to be pretty weird, and it used to work. Matlab, वही logic था, but I just changed the way I used to use the terminology. So one day, one of my friend came and said, "Explain this." I started like this. NO2 is a bad person. He was looking at me like, "NO2 bad? क्या बोल रहे हो, boss?" Said, "अरे NO2 steals electrons. It's a bad person." He was looking at me, meaning that one word, NO2 is a bad person. His fuse blowed off. Then he said, "Arun, what are you talking?" And he left. So people never used to ask me chemistry doubts. Physics is fine, but chemistry was something out of the world. That is one of the reason, my teacher always used to ask, "Arun, when I ask you, you don't tell in the class, but how do you score in the exam?" So one day I told him, sir, I do like this correct. He was laughing and he said, idea wrong nahi hai. It works. Getting it? But future mein, when you want to do MSc chemistry and all, then this will fail. I said, no, sir, I will never do chemistry after this. So that's what I'm saying. Keep that in mind. Getting it? Teacher ka perspective alag hota hai. As a teacher, I want to make sure you will be able to do the question in the exam. Even if it takes 1 minute extra, I want you to get a right answer. But as a student, your job is to get the right answer in less time. So if there are two, three methods, you are comfortable with one, you are confident with that method, you should go ahead. Clear with this? And your teacher will be actually happy for you because there is something more efficiently working for you. That is, as a teacher, that is my whole purpose. You should become better than me, at least on the day of the exam, so that you get a better rank than me. Let's see the next one. We got a block M here. We got a spring here, K. This is point A. The ground is smooth. Now someone is pulling this point A with a constant speed. Getting it? So the one end of a spring it is attached to the block and the other end is pulled with constant speed. Find maximum elongation. Someone is pulling it. We're not sure who and what, but they're managing it. Same question. If I take the block K and this is point A, ground is smooth, but this time you're pulling with constant acceleration. Same thing. Find maximum elongation. Let's get this. Just to give an idea, you know how will the diagram look, right? The diagram would look something like this. When you're pulling it, this is the block, this is the spring. After some time, the block will go little forward. The spring will also stretch. After some time, the block will go here. The spring will stretch more. You're getting the block is also going forward. The spring is also stretching. दोनों एक साथ हो रहा है. Why is the block going forward? Because of the spring force kx. Why is A going forward? Someone is pulling it. We don't know who is pulling it, but someone is maintaining that speed u. So the block is going forward. The spring is also stretching. So it looks like a caterpillar motion. Huh? It goes like this. It's like compressing and expanding, and it is going front also. It will be a pretty weird motion. So we're not interested in all that, but that is what would have happened. So find the maximum elongation in the spring. This is a pretty good one again. Another advanced question. Think, take a minute or two. It's fine if you don't get an answer. Take a minute, think what is happening, how could you have approached this, whatever. Get the part. Just give it a try, get some water and come. root m by k. Okay. Now, now see. One thing, whenever you get these questions, right, there's a big hint here. Not only in this chapter, any chapter. Keep this in mind. When you hear these words, now this thing is not a physics concept. Huh? This you will learn by seeing a lot of problems. You will realize something. Whenever someone says, when it is mentioned that a certain point or a certain body, anything, or body is moving with, ये word important, a constant. Constant speed or acceleration. Constant होना important है. When you hear this word, solve with respect to that point. Relative motion. You're getting it? Suddenly things become easy. Now this is a thing. Now this is not a physics concept. This, like I said, you will realize when you solve problems. Generally, whenever something is moving with constant speed, अभी देखो ना, can you really study how this thing is going? Block is going front, A is also going front, everyone is moving, right? It becomes more confusing. So, but what if M is there? I take this point A, and if I go and stand on the point A, so now A will be at rest. By relative velocity, this will feel like this is going with you, na? Make sense? Now, doesn't this question look like as if a spring and a block attached to a wall? Making sense? And one more thing, A is going with constant speed, so there is no pseudo force. Since acceleration of A is zero, there is no pseudo force. It is an inertial frame. The first case I'm doing. Second case में pseudo force आएगा. So you're done. So if you're pulling with U here, this block will go M here. Again, this is all with respect to A. A will think I'm not moving only. This will come to rest. This is your maximum compression. This is state one. This is state two. Energy in state one is energy in state two. Initially, the only energy you have is kinetic energy. Finally, the only energy you have is half kx square. X is equal to u into root m by k. One single step में answer हो जाएगा. When you stand on A and look at the problem, it just feels like A is at rest and the block is going back with you. So A will think the block goes and stops here. Again, this is all with respect to so with respect to A, it comes to rest. Ground frame में नहीं है. Since there is no pseudo force, right? I can use work energy theorem. It works. Even if you have a pseudo force, I have to calculate work done. Is this idea clear, everyone? Generally, that is a theme. Something is going with constant speed, constant acceleration. Just go and stand on that. Why so? Logic simple hai. A is moving, block is moving. When two things are moving at the same time, isn't it confusing? But by going and standing on one of them, didn't you reduce one variable? If you go and stand on A, you have to just study the block now. You need not worry about A. That is the reason it works better. Is this clear, everyone? Now, can you do the second part? What if I go with constant acceleration? Try. I'll give you a minute. Yeah, pseudo force आएगा ना, because now logic वही है, go and stand on A, but A is accelerating. That means there's a non-inertial frame. That means there's a pseudo force. Then what is work energy theorem? Work done by external force plus work done by pseudo force is change in kinetic energy plus change in potential energy, or E final minus E initial. You have to include work done by pseudo force. Understand, Max doesn't know whether something is real or pseudo force. It will think everyone is same. You have to find X-ray god, Vihan. तो आंसर ही X में दे रहे हो. So the second part, block M is there. This is A, you're going and standing here. This guy is a non-inertial frame. So at this moment, your velocity is zero. Initially at rest, huh? Initially, second case में A is at rest initially. But now you will get a pseudo force MA. So this person will think the pseudo force is dragging you M. It will stretch till here. This is your max elongation. At this point will come to zero again, because if you have velocity, you'll continue to stretch. And the pseudo force is MA. So work done by pseudo force is MA into X. So this is state 1, this is state 2. So work done by pseudo force is energy in state 2 minus energy in state 1. This is MAX, energy in state 2, potential 0, ground is 0, kinetic is 0, half k x square. Energy in state 1, kinetic is 0, spring is 0, potential is 0, 0. X is equal to 2 ma by k. Right there much. Make sense? Initially कुछ है ही नहीं ना energy. Initially spring is in natural length. Initially you're starting from rest. Block is at the same height. So initially gravity 0, spring 0, kinetic 0. Finally only spring energy is there. Kinetic 0, potential 0. Sure, everyone. Clear? Something like this, you know how they'll ask you? This constant velocity acceleration one. Let me ask you one more like that. Any doubts on this? It's a pretty good question. So whenever you hear that word, right, something is moving with constant speed, go and stand on it. Idea is simple. If two things are moving, difficult to see. When you go and stand on one of them, who is going constant, your life becomes a little easy. So they'll ask a question like this thing. See, we have a cylinder. Radius r. Inside the cylinder, there is a block of mass m, initially at rest. Floor is smooth, everything is smooth. So now someone started accelerating the cylinder with a constant acceleration. Find the max height reached by the cylinder. Magnify maximum reached by the block. Meaning, just to give an idea, diagram would become like this. So initially the block is here. As you're accelerating, the block M will reach somewhere here, na? Because inside is smooth. Reason? The pseudo force will drag you back. So this block will go backward and it will start climbing the cylinder. So this thing will actually keep oscillating inside. It will go to the left and then it'll come down, go to the right and then come down. It will keep on oscillating. So the question is, find the maximum height it will reach. Is this making sense? So if you put something in a cylinder and if you move the cylinder, the block will try to stay there, right? But because the cylinder is going to the right, eventually it feels after some time aisa ho jayega. The cylinder will come here. So this block has to go here. It will just keep climbing up. Find the maximum height reached by the block. Again, the same word, देखा? Constant accelerations means go and stand on the cylinder. Now, these kind of things can't be, taught. You will not find them in books or anything. You have to learn it by experience. Show you the diagram. Try one more minute. Let's see. So look at the diagram. 1 minus a by g, no, right? So after some time, the block will be somewhere here. This is so theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of deflection. They can ask you this also. So theta is your maximum angle of That is a maximum angle it can go up. So initially block used to be here. So in this entire process, pseudo force is MA, pseudo force was MA. Be careful, the net force is not zero here. This is your extreme position. Again, forgot, where is the observer? My observer is standing on this. So observer is on the cylinder. So he will see pseudo force. This is an extreme position. So be careful, force is not zero here. The force will be zero somewhere here. At this point now, you get maximum speed. At this point, the pseudo force and the mg component will cancel out. But it won't stop there because you're still going faster. This is one thing most people do that mistake. They think when the pseudo force ka component and mg ka component are equal, they think it will come to rest. When they both are equal, you have acceleration zero, but you have gained a maximum speed till now, so you'll continue to go forward. So that's your extreme position. So great. So let me just redraw it again. Okay, this is interesting. Okay? Okay, I didn't know I can do this. Okay. So this is your block. This is your block. This is your state one. This is your state two. I will take the ground as reference. Gravitational potential energy, zero. Kinetic energy, zero, because you're starting from rest. Gravitational potential energy is mg. H. Kinetic energy, zero. This angle is theta. So if this is r, this length will be r cos theta. And this length will be r sin theta. And this would be r into 1 minus cos theta. That is your height h actually. How is the pseudo force? Pseudo force is horizontal. So what is work done by pseudo force? Remember, we wrote this thing. If the force is always horizontal, what is the work done? F into displacement in the direction of force. Can you see here? The pseudo force on the block is always horizontal. This will be this question. If you remember this guy, F1 is always horizontal. The work done will be force into the horizontal displacement. So we get work done by pseudo force is ma into displacement is r sin theta. This is equal to energy in state 2 minus energy in state 1. There is no other force. Let me show it on the next page, but have a look at this. Any doubts on the equations, please ask. Clear, everyone? So work done by external plus work done by pseudo. Energy final minus energy initial. This is MAR sin theta. E final is MGH. H is MGR1 minus cos theta. Yep, that's it. Everything else is zero. MM will cancel. R will cancel. Sin theta is 2 sin theta by 2 cos theta by 2. This is R into this is 2 sin square theta by 2. 2 will cancel. We end up with tan theta by 2 is equal to A by R. So we get theta is equal to 2 times tan inverse A by R. You're asking for height. What is height? H is equal to R into 1 minus cos theta. Then I can do this almost. This will be 2R sine square theta by 2. Now I know from tan theta by 2, I can find sine theta. This is A and this is R. This is rho A by G, that is. We're writing there. Root over A square plus G square. So this is 2R. Sine theta will be A by A square plus G square. That is your H max, everyone. Yeah, R will cancel, my mistake. Making sense? I know it's all calculations and all, but did you get this step here? If you got this, you are done. It's only calculations afterwards. Any doubts on this? Clear? Next one. Next one. It's a good one. So keep that in mind. If someone says something is going with constant, this is how you proceed. We have a block here, mass M, connected to another block of mass 2m. Spring constant is K. This is the scenario there. So from the initial position, someone compressed this block by Y. So someone pushed it down by Y. So you pushed the upper block by Y and you released it. And we observe after some time when you release it, this is what happened. This block started flying up. And in this process, the 2m, it just lifts off the ground. 2m block just loses contact. But normal reaction becomes zero at that instant for a moment. Just loses contact with the floor. Are you able to visualize how it looks? When you push the block down and leave it, because this m is going up, in this process, it will pull the 2m also up. So there was a possibility that 2m just lifted off the ground. So for this to happen, find a y minimum. If you give y, if you compress the spring too much, definitely 2m will go off. So there's a minimum value for which it just lifts off. The word is that just lifts off. So that the lower block 2m just lifts off. Initially, system is in equilibrium. Then you forcefully pushed the upper block by y, and then you released it. And as this block m started going up, in this process, the lower block lifted off the ground. I hope the scenario is clear, everyone. Pratik? Question is clear, Janil? Arnav? Ahana? Question is clear, Niharika? Let's see. Nee, Poroja. I'll tell you one thing. Is the initially spring is in natural length? Initially, is the spring in natural length? Here, is the spring in natural length? Is it in natural length? So, if this is in natural length, then who is balancing this mg ka weight? Initially, the spring is not in natural length. The spring must have been already compressed. This spring thoda compressed tha. Or else this mg ka weight will not be balanced by anyone. That means when you pushed it y further, spring is not in natural length. It is already compressed by some amount. On top of it, you pushed it by y. I hope you're getting it. Think. Try. I'll give 2 3 minutes. It's a pretty good question. This will be again another advanced paragraph, advanced question. Mg by k. One more question, Puroja. When the lower block is lifting off, is the spring compressed or elongated? So if the spring had been compressed, that also will push you down. Mg is also down, then why will you go up? If the 2m has to lift off the ground, the spring must be in an elongated state. Someone has to pull the block up, and springs pull only when they're elongated. Think. There are a lot of things you have to be careful. Nay, answer. That's not the answer. It's not like kinetic energy. See, 2m doesn't know who is kinetic energy, isn't it, Puroja? The only force 2m knows is the spring force. Because the m is going up, spring is stretching, and because the spring is stretching, that kx will pull the block up, isn't it? Should I show you? Forget about the question. Just think like how will the whole situation look like? Let's see. Again, listen carefully. This is what I keep saying. Analyzing the question from starting to end is the most important thing. So initially, your block looks like this. This is 2m. So the first thing you need to understand, this is the natural length. Natural length is somewhere else. The spring is already compressed by some amount. So this force is mg. This is your kx. And this must be balanced mg by k. That means the spring is already compressed by x. This is compression. I hope that was clear. 4 mg by 3 k nahi Devansh. Then what you did, question still didn't start. Huh? This was the initial condition. Now, then you pushed it by y further. So from this position, You pushed it by y further. Now that means the total compression is x plus y. Agreed? So your question starts from here. Now from this point you left it. This is my state 1. Question starts from here. Now what will happen? This block won't keep quiet. This block is getting pushed upward. It will come. This will be m here. It will have some speed v. Right? Understand, in this process, right, the spring is pushing up. Kx plus y. This spring is also pushing up kx plus y. And getting it? This will continue to go up. So this will cross the natural length and go ahead. Getting it? Let this be some z. This is your elongation. Now this force will pull up kz and this is 2mg. You're getting it? So for the 2m block to lift off, the spring should pull. As long as the spring is compressed, the spring will push you. Getting it? For 2m to lift off, spring should pull. That means it must be elongated. It is not compressed. It must be elongated. Because if the spring is compressed, देखो क्या हो रहा है? If the spring is compressed, the weight is also pushing down. Spring force is also pushing down. N will not be 0. हाँ Daksha, you got that. I think you just messed up an m का value एक m आएगा. You're getting it. So at this scenario, kz becomes equal to 2mg. So z is equal to 2mg by k. Meaning this block here, when it goes to a position 2mg by k above the natural length, then you will lift off the ground. This is my state 2. Since you said for the minimum position, velocity is just 0. This velocity is also 0. You're just lifting off. यहाँ पे भी velocity is 0. इसका भी velocity is 0. Please understand this diagram first. Ask me if you're confused. If I draw one more diagram, I'll draw one more for you. See here. If I draw one more intermediate stage, when it is somewhere here, the spring is still compressed. When the spring is compressed, the spring will push you down. Mg is also down. Why will it go up? No? There is no force to pull you up. The only time when the 2m will go up is when the force is upward. This will come to natural length. It won't stop. It will have velocity. It will still go up and it will stretch. This is your state 2. Please check the diagram. This is what happens from starting to end. All got this? Any doubts in understanding? Pratik? Now you're done. Let's try to solve. So this is my state 1. This is my state 2. I'll just erase all the stuff in the middle. So this is also 2mg by k. Perfect. So this is my state 1. I will take my natural length also as a reference line. I will choose this as my reference. Natural length as a reference. State 1, gravitational potential energy. Minus mg x plus y. It is below the reference line. Kinetic energy, 0. Spring potential energy, it is always compression from natural length, half k x plus y whole square. Here, gravitational potential energy, mg, 2mg by k. It has gone above the reference line. Kinetic energy is 0. Because you said minimum speed, it will just come to rest. Spring energy, half k x square. That is half k 2mg by k whole square. That's your energy 1 and energy 2. Energy in state 1 is equal to energy in state 2. This would be minus mg x plus y. X is mg by k plus half k x plus y whole square. I think I better write in the next page. Minus mg, x is mg by k plus y plus half k x plus y whole square. Mg by k plus y ka whole square is equal to final is 2m square g square by k plus, that is 4 by 2, so 2 plus 2m square g square by k again. Perfect. Then just expand this. Minus m square g square by k minus mgy plus half k. This is m square g square by k square plus y square plus 2mgy by k. It looks bad, but it does cancel out. 4m square g square by k. This would be mgy, this term, and this term cancels off. And then this would be half k y square. When it goes that side, that will be 4 plus 1, 5. And this is an half here. That is minus half. So 4 plus half is 9 by 2 m square g square by k. You will get y is equal to 3mg by k. Check. Simplifying is fine. It looks bad, but it does come out to be a good answer. The main idea is this, that the spring is elongated finally, and initially spring is already compressed. Please check the steps. Any doubts on this page, ask me. If you got this, you're done. All sure of this? Any doubts on this? Adi, clear with this? Arush? Sharman? Ishana, got this? Clear, na? Poroja, got your mistake? How are we taking SP if you have taken Earth block system? Can you, Vihan, can you tell me what is SPE? Super potential energy. And then spring potential energy. What does spring has to do with Earth?
I think so.
Are God? Tell me now, spring potential energy is because of what? Because of Earth you get spring potential energy? Or is it because of compression and elongation of spring? Making sense? So Earth has nothing to do with the spring, right? That right. Let's see one more. That's what I said. We will do springs separately for a separate day. Springs are a little weird. So we have a block of mass M, spring K. This is in natural length. Released from rest. Gravity is there. Find max elongation. Behind it is like this. When because you took Earth and block as one system, you can define gravitational potential energy. Gravity becomes internal force. Spring has nothing to do with Earth. Okay?
Yeah.
How do we do this? Any answers? Right, Puraja. Again, the question is straightforward. You'll get the answer in 2 steps, but the analysis is more important. See, this is how what would have happened with the whole thing. So initially, the block was here. This was your natural length. So if you look at the forces here, we have mg, we have spring forces 0. So this block will have acceleration downward, which is equal to g. Velocity is 0. The next moment, because you have acceleration, the block will go down a bit. Now the forces are mg, the spring force is kx, but mg is still greater than kx. So your body will accelerate with a, which will be less than g, and your velocity is also downward. So it is actually speeding up. Then it will continue to go further. At this point, you get mg. This becomes kx. At this point, kx becomes equal to mg. At this position, your speed, your acceleration becomes 0. But remember, you're gaining speed. So at this point, your speed is maximum. This will happen at when x is mg by k. This is also called as mean position. Mean position or equilibrium position is when net force is 0. But the body won't stop. Why? It has maximum speed. This will continue to go further. Now at this point, mg is still there, but your spring force has increased. Now mg, kx becomes greater than mg. That means even though your velocity is down, your acceleration is upward. You're slowing down. And if you hear speeding up, so just look at there. So here speeding up, here slowing down. That means this is the maximum value in the middle. And then what will happen? It won't stop. You're slowing down, but you didn't stop. You will continue to go further. And then finally you stop. This is your maximum elongation. At this point, the spring force is maximum. This is mg. Kx is greater than mg. So the spring force is pulling you up. So velocity is 0, but your acceleration is upward. So the block will start going up. Now, as the block starts going up, kx and mg. Again, remember, kx is still greater than mg. So you're going up, your velocity is also up. Speed is again increasing. And then again, you will reach a state where mg and kx both become equal again. Again, you'll come to the mean position. At this point, your acceleration is 0, but you gained again maximum speed in the reverse direction. At this time will be mg, and this is kx. At this point, mg again becomes greater than kx. Weight starts dominating. At this point, velocity is still up. You're going up, but your acceleration is backward. Your speed decreases. And then again, you come back to state 1. This will just keep going in round. So this is your state 1, state 2, state 3, 4, 5, 6, 7, and 8, and comes back to 1 again. And this story just keeps going. This is what happens in the entire question. So in this, if you see, the point of interest is what? State 1 and state 5, no? The point of interest is state 1 and state 5. If they ask you when will you get maximum speed, state 3 and state 6. This is what is happening with this block, everyone. Do check it out once. Have a look at the whole thing. This is important. Meaning what we did right now here, you will encounter this at least 2 to 3 times more, something like this. You should have an idea. It is not about just getting an answer. Have an idea like, okay, this is happening. After this happens. After this happens. This is what I keep saying. When you say visualize something, what do you mean by that? Check it out. Solving is quite easy. That will be straightforward 2 steps. But you should have an idea. This is what is happening. Okay. Now let's consider state 1 and state 5 directly. If it is an exam, though, I'll directly do this only. I'll take state 1. I'll take state 5. Initially, this was your natural length and also the reference. You can take any line as reference. It doesn't matter for potential energy. So gravitational potential energy, 0. Kinetic energy, 0. Spring potential energy, 0. Nothing is there initially. This has gone down by X max. Gravitational potential energy minus mg max. Kinetic energy 0 because you're at extreme position. Spring potential energy half kx square. Energy in state 1 is energy in state 5. 0 is minus ngx plus half kx square. Yeah, that's what I'm saying. If you just want the answer, you'll get it in 1 step. But knowing what happens is important. Have a look at this. Any doubts on this? All clear with the process, right? Let's see one more. Clear, na Devika? Pratik, Devansh, Ahna, clear? Adi, Arush, Vihan, clear. Next thing. This is a standard question. We have a hemisphere. You kept a block of mass in here. So when it is gently pushed, so this block will slide here and it loses contact here. Find theta when it loses contact. This is fixed. Hemisphere is not moving. It is smooth. Get it? This is a standard question. This is like a CET or a Velo or Manipal ka standard result. You should mark it up. Matlab, you see the question, you can mark it and come. There are variations of this. What happens if the sphere starts moving? What if you already have initial speed and all? But let's see the standard one. Right, Arya. Hmm. Just draw your free body diagram. So initially block was here. You're saying when it comes somewhere here, you're losing contact. So if this was theta, what are the forces? Normal reaction. This was mg, so this was theta. So if you look at the components, this will be mg sine theta. This would be mg cos theta. So your mg cos theta is trying to keep you on the ground. And since it is going in a circle, there'll be a centrifugal force mv square by r. If you look at this height here, if this is r, this is r cos theta. This would be r minus r cos theta. This was your state 1, this was your state 2. And your velocity is v. So if you look at the normal reaction here, n plus mv square by r is balancing mg cos theta. Since you're losing contact, n becomes 0. So we get v square is equal to rg cos theta. This is the speed when it loses contact. Next thing, energy, if you look at state 1 and state 2, loss in potential energy is gain in kinetic energy. Or I can define state 1, state 2 also. So it has fallen a height of mg r into 1 minus cos theta. That must be gain in kinetic energy of mv square, which is rg cos theta. mgr will cancel off. 1 minus cos theta is cos theta by 2. Cos theta is 2 by 3. And the best thing, it is independent of radius. Cos can't be greater than 1 god. And the best thing about this, we see, independent of radius means you take a small sphere or a big sphere, you're always going to slip here. This is the reason why if you ever go to a park, no one will construct a, slides like this. They construct slides like this. Just imagine if you construct a slide like this, you put the kid here, kid will go, they'll lose contact, kids will fly. You're getting it. So that it might look fun, but yeah, kids will start flying in the air at this angle. There is a friction and all, so they might slide somewhere here, but they will lose contact and fly. So it's a pretty bad idea. That's the reason slides are designed this way. So the kid is always in contact with it. Clear? There, this is the standard question there. I'll give you a homework question. Try this. Next class we will discuss. So we have a sphere here, initially vertical. This is touching a big block here, capital M. This is a light rod of length L. Mass of the sphere is m. Mass of this big block is capital M. Okay. All surfaces are at rest, initially at rest, and all surfaces are smooth. Now someone gently pushed it. If you just gently push this thing, what will happen? This sphere won't remain here. The sphere will become like this. Now it is observed the sphere just loses contact with the block. No, as it is falling, it will just not keep on going forever. Na? Some point they will lose contact. So this guy was M and this guy was capital M. You can see the gap here, it loses contact. So the sphere and the block will separate from each other when this angle becomes 60 degrees. Initially, both are touching each other. The rod is slightly disturbed. A gentle push, almost zero velocity. Which then pushes the block. So the block also will start moving. They lose contact when the angle becomes 60 degrees. This is an advanced paragraph records. As shown. Find mass of the block capital M by small m. You will not get angle 60 for any mass. For different value of m by m, you get different angles. So for this scenario, what is the ratio of capital M by small m? Is the question clear? Try, it's a pretty good one. Spend some time. It is worth spending half an hour, 1 hour. You have time. Try till Thursday. Give it maybe at least 20-25 minutes to spend. Karo. Think about all the possibilities. It is fine if you don't get it, but try. These are the kind of problems, which will improve your concepts, even if you don't get an answer. Try this thing. So next class, when we catch up, we will continue with this and we will do 1 or 2 more problems and then we'll start off vertical circular motion to introduction also. By next week, we will wrap up the chapter. And next week, we have only 1 class. Huh? After that, you will be getting a Diwali break and then we'll catch up again after that. So before the Diwali break, we will wrap up this chapter though. Anyways, we have done almost 33 questions. You will be able to handle all the questions now except vertical circular motion. Except that, you can do everything. So if you're doing some material booklet, DC Pandey, you can start doing it. Just ignore the vertical circular motion. So, okay, with that, we'll wrap up for the day. So any doubts, anything, do stay back and paper, do resolve. And Thursday, we will discuss that paper also. But any other doubts, anything else, you can stay back and ask, also free to give. So take care, stay safe.